Hello, now we are going to discuss about the monochrome CRT. CRT means cathode ray tube. How it is constructed and the working principles of CRT. Most common type of CRT in the multimedia representation is monochrome CRT. Already we know the CRT means that cathode ray tube. The cathode ray tube is essentially a vacuum tube, that is glass sealed glass tube, which consists of two types of electrodes. One is a positive electrode and another one is a negative electrode. The positive electrode are called anode and negative electrode is called the cathode. The two types of electrodes are available in the glass tube or cathode ray tube. Then the front face of the glass tube is coated with the phosphor material. The phosphor material, that means that it is arranged in the grid of dots. It is arranged in the front face of the glass tube. The phosphor material chemical property is it glow light when the electron beam hits on the phosphor material. Suppose the electron beam hit on the phosphor material, immediately it glows light. That is the chemical property of the phosphor. The phosphor dots is also called pixels. Pixel is the picture element. It is also called picture element, that is responsible for producing an image. Picture which consists of many number of pixel. A picture which consists of many number of pixels. The grouping together of a pixel which form the image. Okay. Then the other positive electrodes, three types of positive electrodes are placed near the cathode. The three types of positive electrodes are G1, G2 and G3. G1 is the control grid, G2 is the accelerating grid and G3 is the focusing grid. These three grids are placed very near the cathode. That is, it is used to control the electron beam. Then the neck of the sealed glass tube is placed two types of coils, deflection coils. One is a horizontal deflection coil and another one is a vertical deflection coil. Okay, the electron beams generated from the cathode are made to hit the phosphor dots, generating spots of light, thereby producing an image. Okay, the CRT is capable of producing black and white image on the screen. It is called monochrome CRT. A high voltage is in between the cathode and anode. We apply or supply the 18,000 voltage in between the cathode and anode. Then immediately the cathode produces an electron beam. Immediately the electron are generated from the cathode. If we supply the electrical voltage in between the cathode and anode available in the sealed glass envelope, immediately the cathode which emits electrons, that is also called cathode rays. It is called cathode rays towards the anode. The beam of electron is controlled by three grids. Already we know the grid G1, G2 and G3. G1 is called control grid and G2 is called accelerating grid and G3 is called focusing grid. The grid G1, that is it controls the amount of electron beam to the electron beam and thereby determine its strength of the electron. The control grid determines the strength of electron, and the grid G2 is the accelerating grid. It provides the acceleration to the electron beam in the forward direction. It accelerates the electron beam in the forward direction. And the third grid, G3, is the focusing grid. It focuses the beam on a single point X on the screen ahead, so that the diameter of the beam of electron which is equal to the diameter of the pixel available in the front face of the glass tube. Okay, then the spot of light is known as the glowing pixel. When the current flows through the deflection coil, the electrical field produced and interact with the electron beam, thereby deflecting the electron beam. Suppose if we apply the electrical voltage in the horizontal deflection coil, then the electron beams are traveled from left to right or right to left. That is, it moves left to right or right to left. Suppose if we apply the electrical energy in the vertical deflection coil, the electron beams traveled from upward direction to downward direction or downward direction to upward direction. Both the coils are used to travel the electron beam within the screen. Okay, then with both these coils are energized required proportions, the electron beams can be moved from in any direction of the screen and at any point on the screen placed in front. Okay, then so initially the electron beams are at the top of the screen, then it travel from left to right. That is called forward trace. Then again it wants to move in the next line of the first pixel. That is, it is called horizontal retrace. Then again it wants to move to the right. It is a forward trace. Again horizontal retrace,